Hello, you YouTube hobbits. Today I wanted to talk a very high level about a very basic data practice, and that's basically full versus incremental pipelines. I'm going to talk about this from a super conceptual high level, so this is just probably old hat to you if you've been around data for a while, but if you're fairly new, this can be sort of confusing. Do you do full pipeline loads versus incremental pipeline loads or something in between, and what does that really mean in the real world? You might hear this come under discussion in the guise of full versus historical loads. That's how some people say it, but it's basically the same thing. It's basically small incremental loads versus full historical loads. Basically, I would say generally speaking, full historical loads done well can be done under normal medium-sized data loads every single day, no problem, but at scale, separate pipelines might be required. Let's talk about concepts of full versus incremental loads. When writing data pipelines that contain data loads of some sort, you really only have two options, whether you know it or not. You either are going to do a full historical load, or you're going to do an incremental, aka a recent data load. That's your only two options. It's one of the two. It's either everything or a little bit of everything. Consider this, it's a very annoying problem to deal with because the proper answer, should I do an incremental load or historical load or somewhere in between, or both, is highly dependent on the business and other outside factors. How do you process only new records? How far do you go back to look to see what's new? Can you afford to do a full historical load? Is it going to be too expensive? Is the runtime too long? Can I do that every day, once a week? What are the performance implications? Clearly, there's going to be performance implications, just the cost and money. And how does the data source act? Can it handle one or the other? Honestly, these are questions and answers that change with every single data pipeline you write. That's never going to be the same. We have data sources and we have data sinks. This never changes. What changes is how we get the data from A to B. Which path do we choose? Let's just talk about this in real life. I'm going to show you a straightforward PySpark plus Delta Lake example that pulls only the last 2 days of updated orders from Postgres and then upserts them into a Delta table with a merge, right? This is more of like the incremental load. There's nothing crazy about this code, but a lot of times what you'll see in incremental loads is you'll see some sort of date logic like I have here at the top, pretty much across the board. If you're going to do an incremental load, you're going to start seeing kind of these ideas of dates and time series. At some point, you're going to have some logic in the pipeline that says, hey, what's my cutoff? I'm going so far back. Maybe I'm looking back a week. Maybe it's 2 days. Maybe it's a couple hours. There's going to be some sort of logic that says this is the window or range of time that I'm looking at. As you can see here, recent SQL, right? We just select from the source table where the updated at is greater than the cutoff date. Basically, you're always going to see some sort of logic like that in an incremental load, and that can be one of the trickiest decisions when you're doing incremental loads is how far can I go back? Because do I need to double, triple the size of the data? Do I go back a month? Do I go back a week, 2 days, a couple hours? What is that going to look like and what's the implications? So once we have that sort of cutoff logic, we can go ahead and hit our source table, and then basically the rest of the pipeline, whether it's historical or incremental, is always the same. Once we have our source data set that we've picked, say we went back a week, then we go ahead and merge it up into our target, usually with a primary key, just to make sure, hey, the records coming in here, are they new or not? Let's join on a primary key or some set of columns, insert them if they're new, update them if they're not, or maybe just do the insert. I would call this a very standard practice for an incremental load, which has probably been written a million times over or more recently. Yet clearly for those in the know who've been doing this, what looks simple on the surface has a wide variety of gotchas and holes in it. What if the pipeline itself doesn't run for whatever reason for a few days or a few hours? What happens? How are we going to go back and get that missed data? What if someone comes to us and asks for historical loads? Say, hey, we've got 2018 historical data here. I need you to load it. Well, that pipeline clearly is not going to work. And what if the source blips without us knowing it? Maybe an upgrade or a problem happened and they went ahead and a bunch of stuff came in that table like that's outside our window and we don't even know about it. How would we know that we missed that data? 90% of the time, this query and pipeline, we talked about this kind of like incremental pipeline with this cutoff and look back, this time series probably does the job just fine. But it's the 5% that causes all the problems. You know, when things blip, when you have to go back farther, what do? Enter historical loads are full loads. And can't we always just simply default to full historical loads every time so we can just avoid these issues? I mean, in theory, no matter the technology you're using, it's easy enough in most cases to simply just gulp all the data and do a pump and dump from source to target. Of course, depending on the situation and technology, this will cause a pipeline to slow down to a crawl and costs will skyrocket. I mean, here's an example of that same pipeline where we're just saying we got to get everything. Full source, baby. We just go hit everything out of the Postgres database. Let's just dump it back into our target table using a key where primary key, for example, over a couple columns. We'll just say, hey, when these are matched, either update them or skip them, or if they don't match, just insert the new records. I mean, if we're running something like Spark and we have less than a terabyte of data, it probably might make sense to do the full historical load every time if the source system can handle it, because it's just easier. Maybe you have a distributed system where the compute doesn't run actually that much longer because it can just handle the throughput, but there's a lot of cases where that's not true. Or is there an in-between option? And I've done this option myself. You could call this kind of in-between incremental and full historical loads. And that's depending on your sources. Maybe you can just gather all the primary keys from each table, from the source, from the target, just compare them and only pull new records in. Now, this is highly dependent on if you have to do updates or if things never change. But this is actually simple logic and it can work quite well in many situations. You just go to the source table, you get the primary key, you go to the target table, you get the primary keys, you compare those two lists, and then you say, hey, what's the difference between those two lists? I got the missing keys here. Let me go back and pull those and only those records over. Of course, this is going to work for every data source if things are being updated, but this can be a great option if you have kind of that, you're not sure, you got a huge table, it can't necessarily pull historical loads every time, and maybe the data source acts a little funny, you don't necessarily just want to look back a week, you're not totally sure, this can be a great option. I would like to argue that you just need to find what works best for you and your data sources. Maybe the best answer is just to understand your data sources better and strike the balance where the pipeline doesn't do necessarily incremental loads every time, but gives us some configured option to pull the amount of data you need. That's always possible too. Herein lies a question that has plagued data people for decades. People have been talking about this for 2 decades, ever since I've been working in data, and indicates why data engineers still write pipelines for syncing data, and it's not just all been taken over by SaaS companies. And there's a lot of them who sell ETL tools and CDC tools, and you would ask yourself, well, this problem seems straightforward. Why doesn't everybody just buy these tools and use them? Well, there's a reason for that. It's because every pipeline and every data source is different, probably. Hence, you need data engineers to look at that data, understand it, and make a more informed decision of how are we going to load this data. This involves talking to the business, understanding those source data technologies, how the data acts, and as well, how is that technology act? Can it handle me doing historical loads? Can it handle me pulling all the primary keys out of there, or do I just need to pull the last month or 7 days of data and do my best here? I've seen a lot of pipelines and built a lot of pipelines that strike a balance myself where, say, maybe you're getting tens of millions of records a day, 50, 100 million records a day. And, I've written pipelines where maybe we just do like a 3 or 6 day pull of all those records just to make sure we're not missing anything, even though we know, we're probably only going to get records in that first day. But you never know, let's just pull a week's worth every single day, run the pipelines, check the primary keys, insert the new stuff. Then we for sure are 99% of the time not going to miss any records. I mean, this begs the question that we should probably talk about CDC, change data capture. This has been an approach, and there's a lot of tools out there. SaaS companies, even Databricks gives us auto CDC, and can be a good option. These are basically streaming changes underneath the hood, but they're basically doing what you're not willing to do to write the code. They'll say, we've got a tool that we'll do all that work for you. We'll watch the source anytime a new records hits. We'll send it over anytime something updates. We'll send it over. This can be a good option if things are complex and you don't want to manage that. Yeah, you can offload it to some CDC tool. I mean, look at this DLT code from Databricks that allows you to stream all the changes from one source table to another. And of course, this code is way less complicated. There's way less code to break, etc., than those examples we showed before. So this can be a good option. Again, beauty's in the eye of the beholder. You just need to understand your options. Incremental means get a little bit of data. Historical load means pull everything. Maybe we do something in between where we just compare and try to find what's missing before we do the loads. Maybe we just do CDC because a lot of the companies offer this and just offload that to somebody else. That typically comes with a price, but it's an option.